Well, welcome to our Engineering Productivity Tools Meetup. This is the first one of 2024. And I have to say, I think things are getting better for everyone. We had 4 last year that I thought were pretty good. The Linear B, GitHub, and Copilot. Then we had Lineage. Then we had Code C, and so those were all 4 very interesting things, quite different. And shout out to both Anand and Shania for allowing me to put the videos up on our YouTube channel now. So we are pleased to have with us today, Larry is going to tell us a little bit about Perforce's portfolio. I just wanted to kind of say that they recently sent me an email that I had no idea they had this product. In fact, it was so recent, it was today. And I went and looked at it. It was a dynamite report about open source software, much more thorough in covering things that so they have all sorts of portfolio products that I'm anxious to hear about. But first about Larry. So I won't read this to you, but this is Larry's description of himself, and someone who's been doing managing sales engineering teams for 10 plus years, I have a lot of respect for. I'm anxious to hear what he has to say to us. But I want to just touch a little bit about Perforce and me, because they've been an important part of my life. When I was at Gracenote, I used Perforce for source control, of course. It was really the only game in town except for SVN way back when. And we used it diligently, and in fact, I know they still use it diligently there. When I was at Pixar, we used RCS, and you can imagine that wasn't necessarily industrial strength. But I recently was over talking to their CTO, and he was telling me about how they were using Perforce now for all their source control, but more importantly, for all of their assets for all of their movies. Now, if you can imagine how big the assets for a single movie is, they're incredibly large, HD, and they often do them in stereo at the same time. They used to have to go back and rework them to stereo, but now they often do them in stereo if they think they have a use for stereo images in the future. And so they do all that and all the intermediate work as well. So any system that can take and handle that kind of data, I've had trouble getting, quite frankly, my project, which was on SVN, into GitHub with all the history and everything. It won't accept it. So my little project, of course, it was over 12 plus years, struggles with it. So you can imagine how they might struggle with assets the size of Pixar's. So I have a lot of respect for Perforce and what it's been able to do. But now with all these other products they have, I can't wait to hear about them. So with that, we're going to take and turn the rest of the time over to Larry until about 6:45, and we'll start questions when we wrap it up there, and Q&A. But of course, as always, if you have questions as we go along, make sure you shout them out, and we look forward to hearing what Larry has to say. So Larry, I will stop my share, and if you want to start.
Thank you. Are we rocking now? Do you see a clean screen?
Yeah, that's great.
Super. That's great. So my name's Larry Edelstein. I'm a sales engineer and manage the sales engineering team in North America for components for Perforce. And it was great to be invited here by Mickey to speak to you folks about Perforce, about the products that we have, some of the products maybe that you're not familiar with. I'm going to do that right now. We'll talk a little bit about Perforce. Perforce, it has been around for quite a while. We're here to help our customers solve the enterprise DevOps challenges at scale. We We try to give you the tools and experience to take you through the challenges of digital creation and ensure the quality of your creations, and then help you operate those creations for you and your customers. So what I was noting is that as far as that Perforce is here for those big DevOps challenges, and you're creating, we know that our customers need to create digital products, and we want them to be able to ensure the quality of those products and to be able to operate them at scale for us, for you, for all of their customers. The company's been quite successful. We have customers all around the world, and we count among those customers most of the world's most valuable and productive businesses, I'd say. Our own footprint is global. We have offices spread across the time zones of the earth, as you can see, and we have a growing set of employees that really love to meet the challenges that our customers set before them. And the results are clear. We have very high renewal rates. We've experienced rapid growth in the last few years, and we know that we've got a portfolio of products that represents the best of the industry. Just some figures here. We have what 70%, 77% of the Fortune 100 companies we count as customers. We have 1,000 of the top financial customers, almost all 9 out of 10 of the top semiconductor companies and automotive companies out there. And it's not listed here, but we have, or maybe I guess it is listed there in the subtitle, 19 of the 20 top games development studios use Perforce VCS. So let me go into the portfolio for a little bit here. It's pretty diverse. Sometimes I feel that we have a bewildering array of products. It is a challenge to understand everything. We divide them into 4 pillars, and we consider these pillars in the context of where they contribute in the DevOps lifecycle. First is the pillar called digital creation and planning, and that these tools are for managing large-scale digital content in entertainment and elsewhere. The products that make up this pillar are the one that you're most familiar with, Helix Core, the VCS, sometimes called Helix VCS or Perforce VCS. I may have used several of these terms in my presentation. And of course, that's version control for code and digital asset storage. Helix IPLM, formerly called Methodix, is a tool built on top of Helix Core for IP management in semiconductor development. Helix ALM is for project management, particularly where you have requirements that you want to be able to trace between the implementation of a requirement and the requirement, and then test cases that validate that the requirement has been met. When you want that traceability, Helix ALM is a top tool for you to use. And then Handsoft is a project management tool for big, complex projects, and many of our games developer customers use Handsoft. So that's digital creation and planning. Continuous software quality. These are the tools that engineering teams use to shepherd their products through the DevOps process while ensuring that what they're making is highly functional and it's performant and it's safe and secure. In this pillar, we have Perfecto. So that's our platform for automated testing of products from the UI. You can use Perfecto to test across a very wide diversity of platforms. You can test across many different mobile and desktop platforms, and you don't need to have those devices in your shop. We have a gigantic lab of devices that you can deploy tests to without any trouble at all. It's really a wizardly kind of setup. I need to get to that lab sometime and take a look at what that looks like. I really do need to do that. BlazeMeter is for managing performance testing at scale, and Klocwork and Helix QAC together comprise the Perforce Static Analysis Suite, and that's for assuring the security and quality and standards compliance of your products. And Perforce IT operations, that's about infrastructure, open source management. Again, at scale, I'm going to say at scale over and over because that's what they're about. And for mission critical applications, Puppet, it automates the provisioning of compute instances across your organization. It's there to maintain the stability and predictability with precise and concise configuration management. OpenLogic provides support for many different open source packages that are used throughout your development teams. You may, if you open source is great, it's fantastic to be able to use it. It's also great to have to be able to have someone to help you with your open source packages, to have a throat to choke, as they say, and OpenLogic provides that throat. And Zen, maybe if you've heard of Zen in the past, is there to power web applications for your enterprise. We implement PHP at scale with Zen. And then finally, developer tools, the last pillar. This is the pillar in which I work the most. The components is itself a number of products that includes several code libraries that our customers use to make safe and scalable and supported foundations for their applications. Includes debugging services, which I'll go into in some detail. Akana is for that specialized problem of taking an API, a business API, and making it available to partners, to the public, while still keeping it secure and scalable. And JRebel improves Java developer throughput by solving specific problems, the specific problem of the code redeploy and restart loop. We make that efficient. I'll go into some detail there. And Glyphy is a diagramming and collaboration tool that is available for the Atlassian Confluence market. And I believe that Glyphy is the largest application on the Atlassian marketplace there. So those are the four pillars of Perforce, how we organize our products. Let's talk a little bit about the product that you're familiar with already, Helix Core. As I said, Helix VCS, Perforce VCS, all the same. Helix Core is about the word that I'm going to continue to repeat, which is scale. People use Helix Core to make the problems that come up with mid to large scale development projects tractable, because we support multiple workflows for developers and for designers and other contributors. We help you manage multiple large projects, and we support them throughout the DevOps process. And Perforce VCS is what the biggest and most demanding projects turn to. It's just the best at handling these grand scale projects. AAA games and digital products like those that are produced at the places where some of the folks on the call, where Mickey and Leo have worked, or rather Mickey and Ron at Pixar. You can have these grand scale projects and still preserve the performance across having a gigantic mass of developers who are all distributed across geographic locations and time zones and many different project streams and tons of files, or files that themselves weigh tons. The Perforce VCS also is going to assist with your code reviews and code collaboration, and it's going to integrate with your continuous integration process. And it offers a visual client to help you grapple with that highly branched code base that you no doubt have. And IDE plugins so that your developers can stay productive while they're moving from coding to commit and back. And of course, it's earned its stripes as a hardened product that is safe to use in secure applications. So that's Perforce VCS. But let's move on to some of the tools in the development pillar that I spend most of my time in, as well as some of the other tools here. Let's talk a little bit about TotalView. So TotalView is, we consider it part of our components, but it's a standalone application for HPC debugging. So for high performance computing, for debugging for debugging very demanding multi-process and multi-threaded applications. And you can debug code using TotalView that's written in C, in C++, in Fortran, which might be a name, a language that you didn't expect to hear from for a while, but there is still a great deal of work in the scientific and research communities being done in Fortran. You can also debug applications in Python and in mixtures of these languages. It supports a number of different parallel technologies, MPI and OpenMP, that are used by developers at research institutions, at the government labs like Lawrence Livermore, Lawrence Berkeley labs. I spend a fair amount of time at those places. It supports GPU computing. So if you're building an application that leverages NVIDIA GPUs or uses ROCm to leverage AMD GPUs, you can debug that application using TotalView more smoothly than you can with almost anything else. We implement something called reverse debugging, which is a wizardly feature that allows you to run an application. You can record the whole run of that application or some part of that run and then replay it later, step through it, step backwards. We'll go into that in some detail. TotalView also lets you find memory issues, use memory debugging, finding leaks and double free and use after free and things like that. Going into just a little bit of detail, if you have code that runs on a GPU, the debugger that you're using probably doesn't support GPU debugging. And so if your application starts on the CPU, and so you start debugging in debugger A when you're running code on the CPU, and then now you call a kernel in your GPU, and now you have to move to this other specialized debugger for the GPU, and now you're going to go back and forth, and it seems like a real pain in the butt, which is great. It's a great thing that TotalView supports both your CPU and GPU code in the same application. You can debug smoothly as you move from GPU to CPU and back. We work closely with NVIDIA and with AMD so that we are always up to date with the latest versions of their offerings, and we support the specialized features of their architectures. So a fantastic solution for debugging with GPUs. Reverse debugging, as I mentioned, lets you record your application run either from the beginning or from at whatever points you define, and then you can step back and forth through that recording. So your program can output a bug or it can crash, and then you can go backwards and find out what happened and why, and you can go forwards and backwards. And I'm gonna, time permitting, I'll show you a little demo of how that works. But the ability to record a problem, maybe you've got a rare bug that's hard to reproduce, and you finally manage to reproduce it on Friday evening. Normally you might have to sit there and debug it, but with reverse debugging, you can save the recording, you can go home, and you can have a weekend just like a normal person, and then pick it up on Monday. Hopefully I can show you a little bit of that. It's not
Can I
Friday.
ask a question right there?
Please.
So tools like this, it seems to me like timing related bugs will slip through the cracks. Is that the case?
Well, we do record multi-threaded and multi-process applications using reverse debugging, but what you're saying is true in many cases. We do change the order in which things execute, and so it is possible that reverse debugging will make it harder to reproduce a problem. We do find we do still have many customers who have these very parallel applications that make use of reverse debugging, but it does introduce some delays, and it can change the ordering, just as you are suggesting, Mickey.
Well, you would say it works most of the time?
I think it does. I don't get to work as much with my customers as much as I would like. So I'd like to be able to spend more time with them, but they certainly do make a lot of use of it. They continue, that it is very important to them. So I think that it does. Yes.
Great.
Thank you. To do memory debugging, you can turn memory debugging on at any point when you're running your application. Memory debugging will help you find issues using like leaks and dangling pointers, array bounds violations. It's a little like Valgrind in that respect, but Valgrind, if anyone's familiar with Valgrind, it's an open source tool that many people use to find memory leaks and other memory problems. But Valgrind, when it runs your code, it runs it through a synthetic sort of a virtual processor, kind of like a JVM, and that really does quite a number on your application's performance, which is a pain in the butt for debugging issues. Whereas TotalView uses we use something called a heap interposition agent that allows you to we link a little library with your application and proxy all the memory calls, and so it has a fairly minimal effect, usually a very small, if at all noticeable effect on the performance of your app. So a great way to debug memory issues. We support Python debugging. As I've noted, you can trace if you have a C++ or C program that embeds a Python interpreter, we can show you a combined stack trace from C and C++ into the interpreter and back. And if your Python code calls Python libraries that are written in C++, we'll again show you the C++ stack. It's a fantastic solution for debugging these mixed applications. And I'm happy to talk more about it, of course. So that's TotalView. Hopefully we can get back to a demo of it. Talk a little bit about IMSL here. IMSL is one of our most venerable products. IMSL libraries are exhaustively tested and highly optimized, very broadly functional, and very well supported mathematical and statistical packages. They provide and implement models and methods for data science and machine learning. You use them to delve into data sets and prepare them for further use. You can use them to extract features, make inferences based on the collected data, and then, of course, to train predictive models. These IMSL libraries, they're meant to be embedded in your applications. They're built to scale to support very large data sets and complex models and many iterations, and they're ready to be deployed in your mission-critical applications. They have a very large library of algorithms that they support, that they implement, and they're supported by Perforce, of course. And I should note that the team that supports and continues to develop IMSL, many of these people have been at it for a very long time indeed. We have folks who have been with IMSL and know it inside and out, who've been with IMSL for more than 30 years. It's quite it's the kind of thing that you can base a very mission critical application on.
Larry, a quick question there.
Please.
So are they GPU enabled?
I should know that.
Excuse me.
Our IMSL application? No. As you can see by the look on my face, I'm not sure right now. I believe that they are. I believe I've read that in the documentation. I'd be surprised if they weren't, given the attention that we put into them and the focus that we already have on GPU. But I think that's something I will research and make sure I can answer for you more authoritatively after this call.
Okay, well, it was more curiosity than anything. So
sure.
I think they probably are, huh?
Yeah. Yes, I believe I do believe I've read that. I feel fairly certain about that, but I will follow up with a more definitive answer there.
Okay, great.
And then just to note that we've implemented IMSL in C and C++, in Java, in Fortran, and also we have a wrapper in Python. We have some native implementation in Python, but we found the wrapper to be most performant and useful there. I'm going to talk a little bit about static analysis now and our static analysis solution. So Perforce static analysis, it's here to find bugs before they hit your customers, right? Even before those bugs get into testing, and to help you achieve compliance with coding standards that might be required by your customers, by your regulatory environment, or maybe by your own internal mandates. Perforce static analysis implements rules that cover all of the important safety and security coding standards that are out there. That it covers hundreds of types of common errors that can wreak havoc in your application. And you can also implement your own coding standard and your own custom coding rules, so that you can report on compliance with an external standard, and you can report on compliance with your own standard with just a little bit of implementation. The errors that, or I usually call them defects, but the errors or defects that static analysis finds are logged and stored in a database, and you can use the what we call it Perforce Validate portal to retrieve information from that database to generate reports based on based on the defects found at various times throughout the lifetime of your code base. That will illustrate for you the health of your code base. You can use those reports to demonstrate compliance to your customers. We have specific reports that are for demonstrating compliance or to your regulators, and also you can generate reports and guide your efforts of the development team that way. And then regarding standards, Perforce is an active participant in a number of standards bodies, and it participates in the evolution of those standards, such like the MISRA suite of C++ standards for embedded computing, the AUTOSAR standard for automotive software, CERT C and C++ for secure computing. And we do this so that we can make sure that our customers are able to achieve and report on compliance with the latest versions of these coding standards. Everybody looks pretty sagacious here, but in case anyone is confused, I just want to say a little bit about what static analysis is. Static analysis is about finding issues, defects, code smells in your program without actually executing your program, but by analyzing the source code. We use a technique called symbolic execution, which considers every code path in your application. It looks at every branch, every if statement, every case and switch statement, and follows all of those reachable branches to an almost arbitrary depth, to a very deep depth if necessary. We will bottom out at some point. We will look at every variable where it's used in your code and deduce from our analysis what values that variable can take on. And then from that information, we can note problems like a source of a variable if a variable is set to null in C++ over in a function in module A, and then that value is passed through several functions to a procedure in module B, and then that value is dereferenced. We know that that you're now vulnerable to a null pointer dereference, and we'll issue a defect that pertains to that null pointer dereference. That's one of the kinds of defects that we find. Use of data before it's being initialized, a big C problem, the security hassle for everybody. We find that. Use after free, memory leaks, the use of unvalidated data, or what we call tainted data, another very common source of security issues. We find array bounds violations and memory and resource leaks and lots of other kinds of defects. And it is just better to find these bugs in development than it is certainly in the field, as illustrated by the quote there from the folks at Spirent. And it's even better to find it in development than it is in testing. And I'll go into a little detail there because it's mine. Come on. There we go. Because it's better for your developers if you can find those defects before they hit testing. You know, when you use Perforce static analysis, you're probably going to integrate it into your continuous integration loop. So every time you run a commit, well, you're gonna run a scan of the changed code but with a complete database of information about the rest of the code, all the dependencies of that code, so that analysis can be accurate. And then we're going to report on those new defects, and those can be reported through your continuous integration mechanism, just as test failures are. And we use algorithms to determine which defects are most likely to be important to you, most severe, and most likely to actually manifest as bugs. And that's how you can help determine what to fix. But we also provide highly optimized tools to run static analysis at the desktop so that the developer can analyze their code before they commit it. We have IDE plugins and command line tools that the developer can use as they're working, so that instead of having to commit code, waiting for the continuous integration loop to run the test, run the analysis, send the developer back a note that this happened. We found this defect. We found this test failure. We'll do that right we'll tell the developer before they commit, while that code is still on their desktop, and more importantly, while they're still working on that task. And that's really great, because folks who have actually written code here, which is probably everybody, know that it's so unpleasant to be working on a task, to commit your code, to move on another task, and then get a report that you've got that there's a bug, and now you've got to go back, you've got to stop what you're doing, pay the switching cost of going out of your current context, go back to the old context, load up that code, try to reproduce the defect, try to reproduce the bug, and fix it, and then switch back to the context that you were working on after you were working on the first one. It's great not to pay that double context switch cost. And static analysis at the desktop pre-commit lets you do that, and we can do that in a performant fashion. All of our analysis is highly, we've done a lot of work to be scalable to these large code bases, as Electrovet, the folks have noted. I have just a couple screenshots here. These are large screens shrunk down to small sizes. I'm not that happy with these screenshots, but we have you can sort of see here how Perforce static analysis is integrated into the Visual Studio IDE here. There are defects on the left. A specific defect is listed on the right, and then another list down below of defects in the current file or the current module. And so you can access Perforce static analysis through the IDE, or you can access it through our web interface. Once again, a large screen shrunk down to small size, but this is our web interface. So,
Larry,
yes.
can I ask a question? You showed screenshots of integrated into Visual Studio. What are the other IDEs you integrate with across your tool suite?
See, we are integrated with Eclipse and Sea Lion and IntelliJ and Visual Studio Code.
Oh, and Visual Studio Code. Okay.
Yes.
One other question, and if you're going to get to this, you can just tell me, but I mostly work on iOS development these days. So I'm very familiar with all the Clang suite, and a lot of the static analyzer in Clang is awesome. It does very similar things that you're talking about, and the memory analysis is very similar to ASAN, the ASAN tool that's in the Clang suite. The other thing that I actually didn't start using until very recently was TSAN. And this is a Clang tool that finds race conditions. And those things are so hard to find by code inspection. Like sometimes it's magic. It doesn't, it's not on a static analyzer. You use it on a running program, but it will find, even when you didn't stomp on the other thread, it'll tell you like, oh, this code block and this code block are unprotectedly writing to this piece of memory. Do you have a tool in that part of the space?
ASAN and TSAN. We don't. We in the past we had a tool called Thread Spotter that did some analysis like that. It has been open sourced, and I think that's been picked up by another company. At the moment, yeah, I think we don't have that tool.
Okay, yeah. If you ever get it, it's integrated really well in Xcode. It's part of Clang, so it's in the open source project, but it's integrated really well in Xcode. And it's the couple times when I've suspected a race condition, and it's just like, oh, your race condition is here. It's been really magic. So definitely worth checking out if you get a chance.
I would like to check it out further. Everything around LLVM and the tools that descend from it, like Clang, I'd like to spend more time with. So thank you for bringing it up. I will note that the static analysis that our tools do is, I think what Clang does is very good. The point that I like to make is that our static analysis is significantly interprocedural, so that we're going to trace, the life of a variable across many different function calls, and resurface to you defects that won't be found unless you can do that kind of analysis, and the Clang analyzer is not capable of doing that kind of analysis. I'm going to talk now about JRebel.
If I could insert just a comment before you move on.
Please.
just about static analysis is a great kind of story. When I was at Gracenote, we did a lot of embedded software, and we sold them into consumer electronics products that shipped without the ability to update. And the ability to take and try to make sure your code was running right was kind of important, because otherwise it would cause massive recalls of cars or car stereos or home stereos or what have you. And so I had to go in and try to convince my CFO to buy Perforce. And at the time it was hundreds of thousands of dollars. I have no idea what it is now for our particular configurations. And as a young startup, that was a difficult conversation, although he bought it and we bought it and we were never sorry.
Thanks, Mickey. It's I would paraphrase what you say and often say that static analysis seems to be most important when the cost, when either fixing a bug is very hard because it's deployed in an environment where updates are very expensive, or where the cost of a failure is very large, where it's deployed to many different people, or of course in applications where enterprise funds or loss of life is a possibility. So and it ain't terribly cheap now, but you don't need to pay, at least to start out, you don't need to pay hundreds of thousands of dollars. Probably get into the 5 figures pretty quickly. And of course, if you know, for larger deployments, it does get up there. Thanks. So anything else about static analysis anybody wants to know or say? If not, then let's talk a little bit about JRebel. So JRebel is a very targeted product that's here to make your Java development flow more smoothly and more efficiently by fixing a problem with Java development that really needs to be fixed. It's there. It eliminates that time that's associated with the build and redeploy and restart cycle of Java development, which every Java developer who's working on an enterprise application, I'm sure, is familiar with. So you pay a cost every time you make a change to your code, and that cost, just like what we were talking about earlier with static analysis at the desktop, that cost is incurred by the flow of your developer. And even so, when your developer makes a small code change to your application, even a very small code change, like there's a typo on the slide here, and if I go and fix that typo, then I'm going to change my code, and I'm going to incur this big time sink of redeploying code probably to my application server, and restarting that application server in the application, and then reproducing the state. We're getting back to the place where I was in the application. That can be 5 minutes, 15 minutes for many developers, and some developers, I think, kind of like that chance to go away, and in the past they would have had a cigarette. Now they probably just have a cup of coffee or a boba tea, but it is an impact for a lot of developers that they would prefer not to spend, and I think most development teams in general would not prefer to. And so we've solved this problem of hot deploying, I think is what I would call it, by pardon me, for the most important tools that Java developers work with, for most of the frameworks and the IDEs and the build environments, build tools that JVM languages that Java developers use. It's a very targeted. We solve with JRebel a very well-defined problem that was technically very difficult to solve. We solve it conclusively, and across this wide variety of the most important tools. I've just listed a few here: the IDEs, app servers, and frameworks that JRebel supports. I think you'll find most of the tools at this level that Java developers use. The solution is used by a wide swath of our customers, some of the most important, biggest Java shops around, Oracle and SAP, Salesforce, where I worked for many years on a very large Java application, and I wish we had JRebel at the time. It's a it's a boon to development teams, and we think it's really important. We've got studies that show that developers can spend so much time in that redeploy and restart loop that JRebel can give them back, up to a month of work per year. Because every time, every time you restart that web server, it can really slow things down. And we're going to support local application servers as well as remote application servers. If you're a developer using a remote application server, as some do, JRebel bridges the gap to get that hot deploy, that fast reload. There's a JRebel plugin in your IDE, one of the ones that we listed earlier. It's going to take your code changes, it's going to send them across the network, and then there's a JRebel agent on the remote app server, which is going to take that code change and do the hard work of updating the remote JVM so that you have your state, but the code's updated. And I think that is all I had. I have a few slides here that I don't think I'm going to be able to go through now. So I can now I can take a few more questions. I'm not going to talk about visualization. I don't think these products are that relevant to this group here. I can take some questions now, or I can do and then I can do a demo of TotalView and reverse debugging.
I have just a couple of questions, I think. So, I didn't see anything about JavaScript. Are you doing for JavaScript?
We do. So JavaScript is one of the languages that Klocwork analyzes. Sorry, Perforce static analysis, but Klocwork is another name for Perforce static analysis. So we do JavaScript analysis, and we output that to the same portal as all of the other languages there. Let's see. You can test web applications using Perfecto and BlazeMeter. I didn't cover those. I didn't cover those tools. Those testing tools are worthy of their own presentation. Thanks, Leo. Thanks for joining us. And they, those tools know JavaScript and know how to work with it. I wish I had more time to cover those, because they're excellent tools, and they would discuss. They would be very relevant to what you just said, what you're asking about. That's what comes to mind right now. That's what I know for sure, is that those three, both static analysis and those tools, are relevant.
I think that's the only one I had.
Right on. Then I'm gonna get ready to share my my other screen here, and I'm gonna share my VM, which runs. Where is my VM? Which I can use to show you TotalView here. Do you see what looks like a virtual machine? Do you see my VM here called Crow? Yes, thank you. Thanks, Vidal. So this is a VM. It's running on my Mac here. It's a Linux 22.04 VM, and I'm gonna use it. I'm gonna run. Looks like run TotalView here. So this is the TotalView GUI. It's written in Qt. What I'm gonna do now is I'm gonna run a fairly toy application that I can use to illustrate how reverse debugging works. Now, I should note reverse debugging is available on Linux. And right now it's available only on Intel architectures. I'm running on an ARM64 MacBook here. We do expect to have support for reverse debugging on ARM64 architectures. I'm hoping that will happen later this year, but for now we don't. So what I'm going to do is show off another feature of TotalView, which is remote debugging. So I'm going to connect to a server that an Intel 64 server so that I can run, I'm going to run my application there, but I'm going to debug it here using the GUI on my own desktop in my own VM. And thereby we're gonna take a look at it that way. So I've just loaded the application into my debugger. I can see my source code here. It's syntax highlighted. I don't see any. I see an application, you know, a process here, but I don't see anything else yet because I haven't really started anything yet. And what I'm going to do is I'm going to turn on a replay engine here. That is our recording feature. That's red, and I'm going to run my application, and I think it is going to die immediately. I've just hit run, and sure enough, my program has died. I must be a lousy developer because I have a segmentation violation. So that's terrible news, and normally I would just be sitting here with my thumb somewhere and wondering why my application has crashed. But I've recorded everything that's happened in my app, so I'm going to start stepping backwards and see what I can learn. I'm going to hit the previous button here. So we have the debugger buttons that you're used to, right? You know, go and halt and pause and step forward and step down and step up. But we've got the reverse analogs here. Step back, run backwards. Let's step back one instruction here and see if we can find something. So I step back one line, and I can see I'm at this this code here. I'm at the end of function B here. Again, I apologize. This is very silly toy code here. It looks like we ran off the end of this function somehow. And if I look at my call stack, this isn't a very good looking call stack. It's got one frame on it. It doesn't have anything in it that suggests the C standard library or the start of a process. So it looks to me like the call stack has been mangled. And I can hit previous a few times, and you know, I can go back through this return statement. It looks like now I'm iterating over some array V here, and I let's see if I can iterate for a little while here. I want to preserve some of the mystery here. I can step back a few times. It's not gonna. I'm not getting a better call stack yet. What I might do is I might go into my command line here and say, let's see, d-step backwards 20. So I'm going to step backwards 20 steps. And so that puts me back here. I wonder if I run that again. I could probably run that a couple times. And I think at some point I'm going to get a better call stack here. I'm going to start to see my call stack flesh out a little bit here. Boy, this we have overwritten quite a bit of the call stack. You know, I'm not sure. Well, okay, so now we finally got another stack frame, but it still doesn't look like a good call stack. It looks like it still looks like it's been overwritten. I'm curious if I go back to line 50 here before this iteration, if I use the back to function, I'm going to step back to line 50, and I suspect at that point I'm going to have a righteous call stack here. So if I expand this, now I've got this sequence of co-recursion between these two functions here, and I've got what looks like the start of my process here. I can now, I can make some deductions now, right? That I managed to mangle my call stack by writing to this array here. This array V, let's see, if I hover over it, it's gonna, if I hover over it and the demo gods are with me, why are we not why are you not paying attention to me, demo gods? Well, I can pull my I should be able to look at my invalid compilation scope. You know, I actually seem to be having a problem with my demo here, and this is usually a pretty reliable one. What have I done wrong here? Oh, there we go. So I've got, let's see, I've got this array V here. The lights have turned off in the building. That hasn't happened to me in quite a while. I've got an array V here. It looks like it's been dimensioned of length 20. Okay. That sounds reasonable. I'm just gonna drag it over here. Gonna remove the old one that I tried to put there before it was ready. I could look at array V. I could look at the V, and we could drill into it and see the what's in the array and interesting stuff there. But for me, the most interesting thing is that it's of length 20 because this I'm iterating here from the end of the array, and to me to the program the length of the array is 100. That's too long. If I look at array length, if I look at the declaration of it here, it's declared to be equal to max depth. Max depth is a macro which is set to 20, so it should be set to, this is a length, an array length of 20. The array length is actually 20, but we're iterating over it 100 times, but we set this should have been set to 20. Array length should have been set to 20. I'm not sure why it was. Of course, I'm sure why it was because I've done this demo hundreds of times. What I'm going to do here is I'm going to keep an eye on array length, which should be 20, but instead is 100. And I'm going to keep an eye on it here, and I'm going to set a watch point on it. So I've hit create watch point, and now I've got a breakpoint here that is going to break whenever array length is changed. Because it has an incorrect value, we're going to go backwards. We're going to see when it gets set to the correct value. And I'm going to hit run backwards now, go back, and see if I can find what happens. So it stopped at my watch point. You can see that in the status bar. And here, this orange bar here is where the current program counter is. And what do you know? There's a function called bad stuff that we call. In which the array length is mangled. We arbitrarily multiply it. We set it to be 5 times the maximum depth of the array. And that's why this program overwrites the end of the array and overwrites the stack trace and why it crashes. So what you've seen is how we can run this program. We can let it crash, and then we can step backwards through it. We can look at variables. We can step back for a while. We can use the command line to step back repeatedly. And then when we start to get some clues as to why as to what's caused the crash, we can investigate further by setting a watch point on a particular variable and then going backwards until it changes, just as we might do when we move forward by setting a watch point. And that there is a little demo of what TotalView does. We've scratched the surface. It certainly covers, it shows you a little bit of what Replay Engine can do. There's a great deal of other functionality here, which I hope sometime I'd love to show you. Anything I can answer for anybody as I sit here in the dark?
Well, we can't tell you how to turn on the lights, but so I have to say, I expected this kind of support and wish I had it way back when I needed it.
Me too, Mickey. I would have liked that. It's tempting to spend a lot of time coding again in C and C++ now that I have something like this.
Yeah.
It's tempting. We'll see. I really like my job now, but
Anybody else have any other questions there? So I have some kind of higher level questions.
please.
More about your customer base and a couple of other things. So I don't recall your slides in any depth, but did I see any defense oriented customers, or are they just off there because they're off there?
I did have a defense slide. I didn't. I hit it, but yes, we have many defense customers. Certainly, TotalView is used by, as I mentioned, the institutions like Lawrence Livermore National Lab, which is quite a secure place. Lockheed Martin, Grumman, Raytheon. The Perforce static analysis is also used by several of those customers. We have Perforce VCS scattered throughout the industry in many different places. Yeah, we have quite a number of defense customers, including most of the the top prime, if not all of the top prime contractors, and most, if not all of the defense and government lab, the national labs. Yeah, we cover quite a bit.
What about the security area?
So so vendors of security tools I believe we have presence there in static analysis. So who do we have? I can't think of one of those customers off the top of my head. I think I'd like to, maybe I could do a little bit of searching and see. I suspect that we have those used for, that we have folks who use our testing tools that I mentioned, Perfecto and BlazeMeter for security. But yeah, I don't know. I don't know which ones we have right now.
Okay. Well, Larry, I appreciate you taking the time,
Sure.
and especially when you're back in Minneapolis. It's a little bit later than it is out here.
It is.
To take and spend your evening with us and show us some of the tools from Perforce.
Of course, Mickey. Thanks for inviting me.
Well,
Thanks, Larry.
Oh, you bet. You bet, Ron. Thanks for joining me. I'm gonna just put my name and contact information here in the chat.
okay, great.
That's me there.
Okay. Well, with that, I guess we will call the session done. And thanks so much, Larry and Ron, Vidal, C, and Michael, Leo, who's now exited, and I will be posting a video of this and posting also on LinkedIn. Well, thanks everybody for showing up. And with that, we'll say good night and happy perforcing.
Thanks.
Bye.
Farewell, folks.